Welcome back to Master Algebra 1. This is section 2-4. Practice solving equations with variables on both sides. So we're going to apply some of the properties and principles from chapter 1 with grouping and order of operations to isolate a variable and solve the solutions. Let's look at number 1. Notice we have grouping symbols with multiplication on the outside, so let's use the distributive property to distribute the 7 to the h and the 3, and then also do that with the 6 to the h and the negative 3. So we end up getting 7h plus 21 equals 6h minus 18. Let's move the variable to the left-hand side. So we're going to subtract 6h, we're going to subtract 6h, and we'll have 1h plus 21 equals negative 18. So then we need to move this 21 over. Let's take the opposite. So we're going to subtract 21, and therefore we get h is equal to a negative 39. Now we need to check just to make sure. So let's take this 39 and we're going to input it into this h here, into this h here, and see if we get equivalent solutions. We get 7, negative 39 plus 3 should be equal to 6, negative 39 minus 3. This gives us 7 times negative 36 and 6 times negative 42, and we get 252, which is equal to 252. Both are negative. Checks out. Okay, number 2. Don't get confused. Remember this symbol out here, negative sign. Just remember, with no number out here, we treat it as a negative 1. So we're going to distribute a negative 1 through, or think opposite of both terms inside. So we're going to get negative 5a minus 6. And then we're going to distribute the 2 to both. So we get 6a plus 16. Let's again move the a's to the left, and then move the numbers to the right. So we're going to subtract 6a, but we're going to add 6. Subtract 6a, we're going to get negative 11a is equal to 22. Divide by negative 11, and a should be equal to negative 2. Let's plug it back in and check. We should get the opposite of 5 times negative 2 plus 6, and that should be equal to 2 times 3 times negative 2 plus 8. So we get the opposite of negative 10 plus 6, which would be negative 4 inside, so the answer is 4. And we get 2 times, this is negative 6 plus 8. So 2 times 2, which is 4. So that checks out. Go ahead, hit pause. Do 3, 4, and 5. Check back in a few minutes. Welcome back. Notice number 3. You should have gotten f equals 2. And when we plug it back in, we get 0 is equal to 0. For number 4, we get w is equal to 1. When we plug 1 back in for all the w's, you should get negative 1 is equal to negative 1, which checks out. And for 5, you should get negative 1. And if we plug back in the negative 1, you should get 5 equal to 5. Be careful here. Okay. Sometimes it helps to put little parentheses so the x, and so we don't mix up that negative sign or minus sign here. So it's 4 minus a negative 1, which then changes that to a positive 1. So 7, 8, 9, and 10. What we're going to do is we're going to determine whether each equation is an identity or whether it has no solution, and make sure we show it works. So number 7. If we use the same properties we've been using, we're going to distribute through. We're going to get 12m plus 16, which is equal to 12m plus 16. If we notice, those quantities are both the same, those expressions. 12m plus 16 is equal to 12m plus 16. So that right there is an identity. We get itself. Hey, if we actually carry this through and solve it, if I subtract 12m, and if I subtract 12m, and then we subtract 16 the other way, and subtract 16 the other way, we end up getting 0 is equal to 0, which is also true. Okay? So this is a identity. Another way we can look at this is if it's an identity, no matter what number we plug in there, we should get the same answer. Okay? So this is all real numbers for a solution. Okay. Let's try number 8. Well, we don't have any parentheses, so let's combine like terms. We're going to get 7x minus 3 is equal to 10 minus 3x, so that's 7x. Let's move the x's to the left since there is only just an x on that side. So if we subtract this 7x and subtract this 7x, what you're going to notice is the variable cancels out. We get 0. And then we have negative 3 on the other side. So ask yourself, is negative 3 ever equal to 0? The answer is no. So if this is no, and we have no variable, then our answer is no solution. There is no answer that we can plug in for x to get us a true solution. Go ahead, hit pause, do number 9 and 10. We'll check back with you in a few minutes. Welcome back. Hopefully you got 9 is no solution and 10 was identity or all real numbers. Okay. On 9, the z's will drop out, and so therefore we were left with either negative 4 is equal to negative 6, which is not true, or if you actually move the 4 over, you would get 0 is equal to negative 2, which is not true also. Okay, so therefore no solution. And 10, the quantities by distributing through, on both sides we get negative 2j plus 6, which, or if we move the j to one side, move the 6 to the other side, you get 0 equals 0, all real numbers. That is it for this chapter. Congratulations, and a new one for you. Yesterday's history, tomorrow's a mystery. Enjoy today because it's a gift. That's why we call it the present. Bye for now.